Welcome back to another HVAC-Engineering-Techie training video. Today's training video is on life safety fire alarm systems. This video is intended to get you up to speed on what's actually involved in fire alarm systems, how they're managed and how they're controlled, and what the code requirements are within it. And it helps you if you're going to take the fire alarm commissioning course. This one would be a precursor to that course, unless you're really experienced in fire alarm. So appreciate you being here. I appreciate you being a subscriber. If you're not, really appreciate you being one by pushing the subscribe button down below. Give me a thumbs up if you like the videos. It costs you nothing. It's free. It's painless for you, but it's really valuable to me because Google uses that data to evaluate my videos, which keeps me going. I appreciate that. So let's get started on life safety fire alarm system. All right, before we get started, I just wanted to review the videos that are available in the fire alarm series. Got S-13, which is smoke control systems. S-41, which is fire protection systems. S-42 is special fire protection systems. S-60 is life safety fire alarm systems. CX-11 is technical CX of fire alarm systems. So these are the main videos that take. These here are all S-video system videos that are trying to explain special systems. So these are all important, but here's the main fire alarm video for systems, and this is the commissioning one. So fire alarm system is normally at specification 21,000. The commissioning part of it is 800, but the fire alarm specification is all 21. Controlling authority is NFPA 72 is the basic code behind it. NEC, National Electrical Code, and local building codes, because the local building codes all adopt or amend as they need it for their codes. Basic requirements are primary notification. So when there's a fire or a smoke event, they will give notification for that. They can be standalone. They can be integrated system, always secondary. So if you want to integrate, so let's say you want your BAS, your building control system, to get a notification that it's in the fire alarm is happening, because certain things happen to the mechanical system when it's under fire. So you could integrate the fire alarm into the control system, but the control system has to be secondary. In other words, it can't actually do the detecting alarm unless it's got a special rating, and that's UKL 864, which is to mean that system has been rated for a fire alarm system. That's pretty rare. You can do it, but most of the time it's not, because it's too expensive. So let's look at some definitions. Addressable device, a component tied to a digital bus for communication to fire alarm panel. Each device has a separate digital address. So that's an addressable device. Air sampling detector, a smoke detector that pipes air from a distribution network of tubing to the detector. So this is where you can test a large area by having more than one point come into a detector that's basically detecting smoke in that airstream that's pumping in. Annunciator, a panel with indicating lights or alphanumeric displays or other means of status indication of what the system is doing. Central station, a supervising station that is listed for central station service. And this means people that are watching the alarms and see what's happening. Notification smoke, ionization smoke detectors. A detector that uses a small amount of radioactive material to ionize the air between two different charged electrodes to sense the presence of smoke particles. This is one reason you're not supposed to throw smoke detectors in the trash, because if they're ionization type, they do have a small piece of radioactive material in them. It's not harmful to us, but they don't want it in the trash. Photoelectric smoke detectors, obstruction of light scattering. So they look at if the smoke particles are scattering the light, and they look at that. There are also detectors that have both, but that's their protected beam smoke detector, a laser light detection where the beam scans a protected area, and it watches the amount of laser light it receives so that it knows it's got smoke or not smoke. Protected premise fire alarm systems, a fire alarm system that protects a local building and reports the alarm at that location. So that's a fire alarm on just a separate building. But it is also possible to have them on a bigger network and have a lot of things going on. A rate of rise detector is a temperature detector that responds when the rate of rise is exceeded, so it's watching the temperature go up. A VESDA, which is a very early smoke detection apparatus, air sampling tube system. This is the detector we're talking about, where it pipes up air from different locations to a pump and pumps it to the detector, and the detector then is watching the smoke for that way. Okay, code references. NFPA is the definition of fire alarms. It's household fire warning systems for homes. We have fire alarm systems in homes. Protected premise fire alarm systems for commercial or industrial buildings. Class A is a redundant separate path, and we'll get into this in a little bit what this is. Class B is a single path supervised, maybe combined with other system security or controls like I talked about. Remember that fire alarm is always primary notification, though. Everything else it's attached to is secondary. Alarm indication devices, horns, strobes, or speakers used for fire alarm cannot be used for any other service. And I see they wouldn't be, but they can be. Supervisory station fire alarm systems. Auxiliary fire alarm systems, local alarm. Remote supervising fire alarm system supervised by another station. So you can have one building that the main panel is actually watching two buildings. Well, not the main panel. Main panel's in both buildings, but they're reporting to the same station. It's got a person that is watching the alarms. C, proprietary supervising station systems, local central station. Central station fire alarm systems, listed UL station, and we'll talk about that, what that is later. Municipal fire alarm systems, public response, and those are street boxes or phones. So these are the different types of systems that NFPA 72 covers. So input devices. So under the code now, I'm using 1999 because it's a copy I have. They've obviously been updated, but they won't be changing these basic definitions. Local codes have jurisdiction for what buildings and what occupancy requires a fire alarm system. It's a local code requirement. Smoke detectors, spot ionization and photoelectric projected beam and air sampling. So we have smoke detectors. This part of the code says coverage shall include all rooms, halls, storage bases, basements, attics, loft spaces, above suspended ceilings, closets, elevator shafts, enclosed stairways, and dumbwaiter shafts. They all have to have smoke detectors. This paragraph, smooth ceilings, 30-foot spacing. So if you have a ceiling, they can be at 30-foot spacing. As long as the beams don't project more than 12 inches. So if you have beams up there that are more than 12 inches, then every pocket must have one at a spacing of 12 feet. Smoke detectors should not be located directly in the airstream of a supply register because they'll get the detector dirty, is why. And the high air movement areas have increased space based upon air changes per hour, depending on what the mechanical needs in that space are. Raised floors and suspended ceilings are treated like rooms, so you have to have a separate smoke detector in the raised floor, separate detector above a ceiling. So that's kind of the way we do it. Smoke detectors shall not be installed until after the community construction cleanup of all trades is complete and final. Now, what a lot of times they do is they use a special plastic cover over the detector to keep air from entering while it's under construction. If you don't do that, they will fill them full of sheetrock dust, and they'll have to be replaced. They cannot be cleaned. So basically, you don't want to do that. If you're a fire protection guy, you don't want to ruin your stuff, but you don't want them doing that. I have also seen, if you've been on a site while someone's testing this stuff, the alarm is going off all the time, because they're testing every zone, or maybe every detector. And I seen a sheetrock guy. He was working in a room that had a horn, a strobe horn in it, actually. And he got fed up with the noise. He went over there and took a big, his trowel with a big bunch of mud on it and just sealed up the speaker to keep it from making so much noise. It kind of ruined the strobe horn, but that wasn't his deal, so he just wanted to get out of it. So don't do that. Don't install these devices until the last moment of the system so they don't get damaged. So duct smoke detectors, NFPA 90.A requires duct smoke detectors in the supply duct downstream of filters before any branch duct for units greater than 2,000 CFM. If they're below 2,000, they don't need one unless the local code requires it. NFP does not require it. Return air duct at each story prior to common return, prior to any outside air connection for systems over 15,000. So you need a return duct detector on larger units. Exemption: return air duct detectors are not required if the entire area served by the unit served by a network of area smoke detectors. So that's an exemption. It is some spaces. Otherwise, you have to have both. Exemption: smoke detectors are not required on fans that sole purpose is the exhaust air. So, if you have a relief fan or exhaust air, they don't require a smoke detector on them. This one requires duct smoke detectors that are installed at a concealed location more than 10 feet above a finished floor where the alarm indicator is not visible, and the detector shall have a remote alarm indicator clearly labeled. So what normally that is they sell a little stainless plate that has a LED on it, and that tells you when it's closed or open, because it's very difficult if you have an extended duct system with 20 or 30 smoke dampers in it, and all of a sudden your HVAC system starts working, you go try to find the one damper that's closed. It becomes really irritating. So basically they like to be able to have an indication of when that smoke detector's. Another thing I really like is to put a status point into the BAS system. So if your control system actually has end switches on that smoke detector, can tell when it's open or closed, it becomes real easy to see what's going on in the system. So heat detectors must be rated for a minimum of 20 degrees above the highest anticipated room. So normally they're between 135 and 190 degrees. You don't want to get them too low because they're normally up in the ceiling, and we get stratification of space, we get heat that rises. So if you're in a garage or something or an unair-conditioned space, it could get pretty warm, so maybe 190 degrees would be better. So they do come in different ranges. Normally used in high fire or hot areas such as garages and mechanical rooms. Rated energy sensing fire device, fire sensor, spark sensor. This actually detects live flame or sparks. Spacing for detectors are used in the engineering evaluation of the type of fire and fuel source and other determination lists. So this is a special detector used, in real special circumstances. Normally used for special fire hazard areas like large fire sensing, like fuel storage tanks and things like that. Sprinkler water flow detection. Water flow detection shall occur within 90 seconds of water flow at the flow switch. Flow due to waste, surges, or variable pressure shall not initiate an alarm. So this is off the sprinkler system, of course. Automatic extinguisher systems. Special extinguishing systems such as kitchen hood or special FM gas systems shall initiate a fire alarm based upon each system's listing. So they have some little different requirements depending on what they are. Now, FM gas is used in computer spaces that are trying to protect the data. That's a special system. It has real special releasing mechanisms. So that's something you need to understand. NFPA 17 fire code, manual alarm stations. Pull boxes should be located within 5 foot of each exit doorway on each floor. Also, I think I said here, pull boxes shall be located at both sides of any group opening over 40 foot wide. So in other words, if you have one big area and you have another big area with a exit door between them, then the fire pull must be on both sides. So it's just convenience for people not having to look for a pull station. Pull boxes shall have a minimum spacing of 200 feet measured horizontally on each floor. Coded pull boxes addressable systems shall send 3 separate coded signals, at least 3 impulses each. So what they're trying to make sure is that when a pull is a very serious one, because when somebody alerts a fire alarm, they want to know right away. They want to guarantee that the address gets through. It's not that they don't have problems; they just want to make triple sure that it does. Control valve. Control valves shall have 2 signal indicated. The first should be the valve is at normal position. This is on fire sprinkler system. So this is a shut-off valve is what it is, and they want to know if it's fully open or fully closed. The second signal shall initiate when the valve is moved from its normal position within the first 2 revolutions of the hand wheel. So they want to be able to tell that someone is opening or someone is closing the valve, and those go into the fire alarm system as trouble alarms. Pressure signal indicating device. Pressure tank signal shall indicate when the pressure increases or decreases by 10 psi. System shall signal when normal pressure is achieved. And this is on a dry pipe system that uses compressed air as the fluid of detection. So we put pressure sensors on those to tell what pressure we have in it. Dry pipe season pressure signals shall indicate when the pressure increases or decreases by 10 psi. System shall signal when normal pressure is achieved. Now, one's a tank and one's this, in case you have both. Tank water level signaling device. A pressure tank level device shall indicate when a tank level increases or decreases 3 inch. System shall signal when normal level is achieved. Now, the code here says pressure device, but there are different devices that will apply also besides pressure. The only reason I'm saying that is because a smaller tank doing pressure is somewhat tricky because it needs to be pretty accurate. But a big tank's not a problem, but they do that. A tank level device shall indicate when a tank level increases or decreases 12 inch. System shall signal when normal level is achieved. And this is actually probably a float. Okay, alarm system functions. These are the inputs to the fire alarm system. We've got smoke detectors. We have ionization. We have photoelectric. We have laser beam detection. We have very early smoke, or the VESDA systems. So these are different kinds of smoke detectors. Laser beam is normally used for big spaces like atriums or gymnasiums or something like that. The detection, if the smoke detector is 40 feet in the air, it's not good because it needs you might not see it. The plume may be in one place. It may take 4 or 5 or 10 or 15 minutes for that smoke to get where it needs to be or dense enough to make sure it detects. So they use these laser beam detection or maybe even a VESDA to do that. Heat detection. It's heat detection, of course, just looking at heat and looking at the heat rise to see if we have the heat in the space would be on normal altitude, and they'll do an alarm for that. Products of combustion, that's what it's one I've seen flame. Manual fire reporting, pull stations, fire sprinkler systems, flow switch and alarm, and tamper trouble alarm, the two things, or pressure alarm, loss of air line, dry pipe. Fire alarm output devices, mechanical horns, electrical horns, bells, speakers. A device shall provide 15 dB above the average ambient sound or 5 dB above the maximum sound pressure level during a duration of at least 60 seconds, whichever is greater. So the speakers, normally when we're commissioning a job, we test to see how loud the horns are because they're required to have a certain decibels. Strobe lights requires devices produce a minimum of 0.0375 foot candles per square foot of all occupied spaces where visible notification is required. And that's pretty much everything that's occupied needs visual indication. Typical ratings are 15, 30, 75, and 110 candle area. And this is another thing that you can test. You need to have a light meter that will do that. Field of view is important as well as mounting height because you have to be able to see these. An occupied space needs to see that alarm and hear the alarm, actually. To prevent seizures to people who with photosensitive epilepsy, more than one visible plan is not permitted in any field of view unless flashes are synchronized or they are more than 55 feet apart. But basically, I think most all the detectors now, all the strobe lights are capable of being coordinated. So what that means are some people that if they see a certain pattern of flashing, have a seizure. So that's what this photosensitive epilepsy is. So what happens, we just make sure that they go off at the same time and then the pulse is slow and it doesn't happen. So here's the output: smoke dampers, electric, hardwired, addressable relay is permissible, status feedback, ceiling light or BAS status. Now, we used to do some of this with pneumatic, but you don't see those anymore at all. A photoelectric, pneumatic electric, used to have those, but I haven't seen one in years. Status feedback, ceiling light, BAS status. You need some kind of status for these pneumatic ones because they're not going to feedback unless you put it to the BAS station. So what they do is they use a ceiling light to tell you this damper is open or closed. Smoke fan, exhaust fan, HVAC unit control, fireman's panel. So these may have normally what happens is a regular HVAC system, the unit is shut down upon a fire alarm. However, if the fireman needs to wants to turn that unit on to pressurize the space, then the fireman's panel will allow him to turn it back on or to turn them off. So the fireman panel allows him to turn on and off fans as he sees fit. Smoke control sequence for the HVAC fans. It is possible to have smoke control sequences for HVAC fans. Condition is that if you're going to use an exhaust fan or a HVAC supply fan for a smoke control event, then their drives have to be double the horsepower. So in other words, if you have one that's belt driven and it's a 5 horsepower fan and it's got a C belt on it, which is good for a 5 horsepower, then you have to have 2 of them. It's just have to double that. They're just trying to make sure that that's not got a broken belt on it. Then elevators and escalators, when you shut them down upon alarm. Fire protection system release. This is like a pre-action fire alarm system where the fire alarm is actually releasing the water. Fuel fire systems, which are dispensing foam or whatever, skin, CO2 for kitchens, FM 200 for computer rooms and that kind of thing. Foam. And by the way, there's 10 other materials, but they're all special clean gases called clean gas, and they do put out a fire really quick. This will, once this triggers, and these systems are flood systems, so they basically just dump a whole bunch of this gas into space. The gas is heavier in air, it goes down, and it'll put a fire out in a second. It's amazing how fast they work. The only problem is they're not breathable. I mean, they don't hurt you, but they displace oxygen. So they can only be that they want that air charge to go into space, put out the fire, and then ventilate out in case there's people still in space. So before that stuff gets up to their breathing point. And then, of course, there's foam. Alarm notification, horns and speakers, voice enunciation. Some systems have voice, whereas they have the capability for firemen. At the main panel, he can take that phone and he can broadcast either by zone or by area commands. So that's voice systems. And, of course, strobe lights. Local and or UL monitoring station notification. And what a local supervising station would be someone like a guard station that they have a panel in there to tell the guard there's a fire. So now he is active and knows there's something going on. Or if you have a remote station or a UL monitoring station, which basically is a remote service, and when your system alarms him, depending on the type of alarm, they have a script to follow. And you've set this script up that says, okay, you're supposed to call this person, you're supposed to send this text, and this is the sequence you're supposed to do to make sure the right people know that there's a problem in this facility. And that's what the service they provide. System common requirements: 2 or more power feeds. Normally have a normal power, backup batteries, and emergency power. Normally all fire alarms on emergency power. So you have redundant here. You actually have 3 normally that's required. System approvals. Design review by authority having jurisdiction, the AHJ. And that's normally local code official record of completion. Special system inspection is required by the AHJ. He may have some special requirements that are unique for every jurisdiction. And then functional test is normally by a fire marshal. May not be. The AHJ may do that themselves, but normally it's a fire marshal. Someone connected with the fire department is doing the final testing of the fire alarm system, normally. Fire alarm devices, system panels. So you have front-end panels with computer screens that can see what's going on within your system. You have fire alarm primary panels. This is the main brains of the fire alarm system. You have voice panels. That voice panel has a phone inside there, and he has ability to select zones. Gas release panel. This is for FM gas, and this is really important why it's a separate panels, because the release mechanism inside these tanks happens within 1/10 of a second or so. It's really fast. Pre-action fire alarm system. This is like for a sprinkler system. Notification annunciator panels. You can put annunciator panels into these that actually list lights and codes to tell a person exactly what's happening. Fireman's control panel. This is where the fireman actually can control different sections within the system. Component types: smoke detectors, hardwired, addressable, room smoke detectors, ionization, photoelectric, laser beam detection, very early VESDA systems. Duct smoke detectors. Duct smoke detectors are really basically just a regular detector put in a special housing, and you have a dip tube that goes in and samples the air across the duct and runs it across the detector and back into the duct. So, or outside the duct, either way. But those tubes are basically running the air through the detector, and it's a regular detector, so it's just in a case. Heat detectors, the ones that do heat. We have CO detectors, carbon monoxide, which is a byproduct of combustion that you can't breathe. Spark combustion detectors. Pull stations might look like these old ones, so might look like what new one. Strobe lights, horns and speakers, flow switches for sprinkler systems, control valve tamper switches. This is a tamper switch on there that lets you know what is going up and down. And then dry pipe pressure sensors. So those are the kind of sensors. Now there's a lot more of them that look a lot different, but basically these are the basic types. They keep trying to do things differently, so you never know, but this is pretty much everything you need to know. Fire alarm control protection systems, wet pipe sprinklers, dry pipe sprinklers, pre-action sprinkler systems, both single and double interlock systems. Now, to understand these, you need to go watch the fire protection video. Deluge fire protection systems, and all of these are controlled or alarmed from the fire alarm panel. Foam fire protection systems, kitchen gas fire protection system, which is normally CO2. Clean gas fire protection systems. For details of these systems, see training videos S41 for fire protection sprinkler systems and S42 special systems, and I'll explain all these to you. All right, here's a basic, simple wired system. See, it has a panel. This one has an annunciator on it. It has a bunch of detectors and a bunch of outputs on it. All hardwired. And that's the traditional way of doing a fire alarm system. Is the devices are hardwired to the panels, and then we have what's called a multiplex system. We don't use these much anymore, but what happened with these, they had individual systems on panels that actually put all this data on a network, and the network went to the main panel. So these are hardwired into these panels, and these networks are back into the main panel. Multiplex panels concentrate data into a network. This is an addressable system where they're all on a bus, and each one has an address, and it knows how to do it with the address. So these panels just go over these network devices. Addressable devices, network panels, bus or network device. All devices have separate addresses. Okay, wireless systems. This is something we got to kind of mention here, that almost all residential systems now are totally wireless. The wireless hasn't come to the commercial market quite yet. It is. I mean, you can buy detectors that are wireless, but they're not widely used because of the timing. So wireless components, less installation costs, are certainly less cost. You don't have to wire them up. Battery notification maintenance is a pain. The system will tell you when a balance is getting low, but if you've got something with 200 detectors, I don't know, wireless is going to be a nightmare for that. And also speed of alarms. They can be from 5 seconds to 2 minutes, which makes them not acceptable for commercial. If you have a very important, like a heat detector or a spark detector, and you want it to take 2 minutes, I don't think so. Not going to happen. You know, you need, or a smoke detector for that matter. You want it to take 2 minutes to report an alarm? I don't think so. And then there's always this problem with blockage of the... there's always this problem of having a communication error because of interference. And you don't have that on wired devices. So even though wireless is there, I don't think it's really for prime time for commercial. Normal installation is wired for input pull stations and water flow alarms, and wired for output strobes and horns, and some wireless for smoke detectors. I haven't actually done one that I have my own homes. I have 2 houses, and both of them are wireless smoke detector or wireless fire alarm systems, and they're not really that good. I mean, because originally I had the house wired total, and when I got a new system, they said we don't do wired anymore. We only do wireless. So they had to convert everything to wireless. And it was like the blind leading the blind. It was a nightmare. So I'm not a fan of wireless because I think it's great. They're really nice, but for the lack of detection speed, I think is a killer for them. Most residential systems are totally wireless. So smoke control systems, that's smoke compartmentalization, smoke devices, smoke fans, smoke dampers, smoke doors, smoke detectors, fire pulls, fire alarm, strobes, and horns, just like a regular system, requires special testing. So smoke detector, a smoke zone system are basically for life safety to protect people. And normally these are stairwells and elevators, but they might be corridors. You're trying to get people out of the building, they got to go through a corridor, then that corridor might be a smoke zone. So what happens here, this is a stairwell. And what happens, you have a pressurization fan on the roof that's designed to come on and pressurize the stairwell for a fire vent. And then what happens is this is a smoke exhaust fan. It comes out, and what happens is you have dampers on every floor. And you can see if we had a fire on the second floor, then this damper here would be open, and this damper here would be closed. It's not wanting any air into the space. It's going to get rid of the smoke through this smoke exhaust system. And this damper will be open, and this damper will be open. This is closed, and this is closed. So basically what's happening is it's pressurizing this space, and of course the evacuation route is pressurized with fresh air. And so what happens is these are safety zones right here on these platforms. When a person comes out onto the floor, they should be able to stay here in a protected zone until someone help comes. So like if you're in a wheelchair or something, you can't go down the stairs. So they're there until someone comes and rescues them because this is a protected area. And these are pressurized to help this, that the smoke doesn't enter these spaces. It's trying to keep them smoke free. And that's how that works. And you put a system in to maintain that. And this is a fire alarm system that has strobes and horns, door pulls as specified, runs the fans through an addressable relay. So and does the dampers versus addressable relays. So that's the way those work. So it's got a mechanical system, but basically it's strictly for smoke control. So you can't, the pressurization of the stairwell is always a separate fan. And a smoke exhaust fan might be part of an air conditioning system, but not normally. Normally a specialty smoke fans. And where you'll see these a lot is at atriums. So that's basically a smoke control system. UL stations, alarm management, scripted response, 24/7. Automated systems, more than one response modification possible. And basically they have people that actually actively monitoring the systems, unless it's an automated one, which I've never done one of those, but they're actually rated by UL. So they're not just anybody. I mean, you have to have an approval that goes into make sure you're 24/7. So this gives you peace of mind. I know my personal home is on a UL station. So that basically if the fire alarm happens, they actually, if I get an intrusion alarm or a fire alarm happens, they call the right people to get onto the house. Get a false alarm, it costs you little dollars, but not much, but at least it costs you something if you send out a false alarm. All right, so this is the difference in class of systems. It's all about the supervised. So this is a supervised Class A circuit, which means that so if you have a wire brick right here, and you have this double connected system, which is Class A, then this detector still works by this connection, and these detectors all work on this connection. So if you get a break in a wire or failure of a wire, everything is still active. A Class B circuit is one that it just has a single circuit. If you break, and then these become non-operational, and only this detector is operational. So supervised Class B, and what supervised means is it detects whether you have an open wire or not based upon the resistance reading of the wire. because they put an end device on it that has a certain resistant reading, and you can tell if you've got a break somewhere in the wire, and that sends a trouble alarm to the main panel, so you can tell what's going on. This is a supervised Class B separate power devices. So if you have a bunch of detectors that have separate power on them, that's not coming through your system, they're just wired off either house power or something like that. And then this is just detection, and they're wired in this fashion. If you have a Class B integral power detector so that the power is coming from the main panel, they would be wired like this. It's no big deal, but it tells you there is a difference between those two. And remember, on fire alarm systems, normally they're on emergency power. So if there's a generator to start the emergency power, they're also on battery. The main panels are all under battery power, and they require 24 hours of backup for system operation. So system integration, you can integrate a fire alarm in with an HVAC control system. If you want the control system to actually do some detection or some actual output for fire alarm, it must be UKL 864 listed. And that's just a listing that the controllers have that allows it to be used for fire alarm, which means it's more robust. It's been tested to be robust enough to do that. Smoke control, fireman's control panel. Fans used for both HVAC and smoke control must have belts and shifts that are double the horsepower, like I mentioned before. So there's different ways you could shut a HVAC unit down with smoke detector. The first one is we have a smoke detector here with an auxiliary contact on it, and the fan controller wire goes through to the fan. So if there's a smoke detection, that auxiliary opens up and stops the unit. Next way is to use a fan off through a fire alarm relay. If you have a smoke detector that's part of the fire alarm system, not connected to the unit in any way, but an addressable relay is to break the circuit in this normally closed, so it'd be normally open when you have a fire alarm, and shuts the fan down. Or this one here is fan through a controlled integration. So this is one that needs a UKL. So if you have a smoke detector, which is part of the regular fire alarm system, and he puts an input into the controller telling it we've got a fire alarm, and that would shut it down. All right, so design documents. What kind of design documents did you see on a job? So this is first thing, you should have a symbol list. And the symbol list should list all the symbols and all the nomenclature used in fire alarm units. Now, one thing I always look for when I'm doing a design review or whatever is hopefully these are what they show on the drawings. Every once in a while, they'll take this as their standards, and then they'll go invent a new one somewhere on the drawing and forget to put it on the schedule, so you might look at that. This is a fire alarm layout drawing, fairly common, which just has different symbols, which is off the symbol sheet for the smoke detectors. You can see all the smoke detectors up here. These are some VAV box smoke detectors, so you see a lot of different things, and this is how they lay it out for you to know where they're at. And then, of course, there should be a fire alarm tree riser. And this basically says, here's the main panel. This is the different feeds I have going off of it. This is going to a different panel. And it explains what the riser looks like. And it should have every single device that's connected to these trees. Not just typical. It should have a tree, so you know in which order they're connected also. And this is the fire alarm sequence of operation. This is what we test to. And this, the designer is telling the fire alarm contractor what's supposed to happen. So if this trips, what's supposed to happen? And the way we test these is we do exactly that. We trip this, and we go over here and record what actually happens to make sure everything it's supposed to do is actually completed. It's not difficult to do, and but that's why these are important. Without this, you're testing to generic sequences, which is not be good. There should be a fire alarm sequence on every fire alarm job. So fire alarm installations. Project specification dictates type of raceway and cable. Normally conduit and cable are required to be red in color for fire alarm identification. All fire alarm network or communication conduits and cables must be run separately from any other craft. So you can't combine fire alarm with security cables. Fire alarm has to be separate. Fire alarm system must be source of primary detection and alarm. Any integrated system may only initiate secondary alarms unless they're UKL 864, rated for fire alarm service. Most municipalities require fire dampers and smoke and fire dampers installation be inspected by a special system inspector to verify they are installed in accordance with the UL label requirements. So it's really easy that we do that as test and balance guys, is go out and check to make sure, and it's mind-numbing because you have to make sure it's mounted exactly like their UL sheet says. And the number of screws that are in the frame, how it's mounted to the wall, all of that is important. If it's not, it has to be changed to match how they had it when they were approved by UL. Fire alarm systems are normally tested and approved by the AHJ, which may be a fire marshal or municipal inspector. And that's it. We made it all the way into fire alarms. I know there's a lot of words, but there's not a lot of pictures you can do when you're trying to describe some of this code requirements. So thank you very much for taking the video. I really do appreciate it, and I hope it was helpful. Have a great day, and I'll catch you on one of the others. Thanks.